Hi, in this video we'll be looking at the comparison test for improper integrals. So sometimes we don't need to know exactly what the value of an improper integral is, and we just want to know if it converges or if it diverges. And moreover, we can't always just evaluate the integral to determine this convergence or divergence. So in order to do that, we're going to compare it to an integral that we already know converges or diverges. And while it works for all improper integrals, we're just going to look at the case from a to infinity to kind of just get an idea of what's going on, and just know that we can expand it to ones that we looked at last time with like say 1 over x cubed. So what's the rule for these? Well, let's say we have a function f and g, and let's say that f is smaller than g on this interval from a to b. Then if the integral from a to infinity converges, so does the integral from a to infinity of f. That is, if the bigger one converges, then the smaller one converges, because we can fit the smaller one inside of the bigger one. And the same thing holds for divergence. If the smaller one diverges, then the bigger one sits outside of it, so its integral value, the value of its integral, is larger than that of the smaller one. So if the smaller one goes to infinity. So let's start by taking a look at an example. So we want to determine the convergence of the integral from 3 to infinity of sine squared of x over x squared. So we know that the sine of x is between 1 and negative 1. Okay. And this tells us that sine squared of x is between 0 and 1. So what does this mean we can compare it to? So if we compare it to, say, 1 over x squared, we know that the sine squared of x over x squared is always going to be less than or equal to 1 over x squared. And we know that the integral from 3 to infinity of 1 over x squared converges. So since this converges, so the integral from 3 to infinity of 1 over x squared converges, and 1 over x squared is always bigger or equal to sine squared over x squared. That tells us that the integral from 3 to infinity of sine squared of x over x squared also converges. Next, let's take a look at the integral from 2 to infinity of 1 over 1 plus e to the x. Now, let's do some analysis on the integrand here. So 1 over 1 plus e to the x is always going to be less than 1 over e to the x, because we're just going to add a little bit to the denominator. So the denominator, 1 plus e to the x, is always going to be greater than e to the x on this interval from 2 to infinity. And that's how we can conclude this inequality here holds. So now all we have to know is the answer to the question, does the integral of 1 over e to the x from 2 to infinity converge? And if we look at it, remember this is e to the negative x, so we can evaluate this, 2 to infinity, e to the negative x dx, and that's going to be negative e to the negative x from 2 to infinity. So that's going to be the limit as b approaches infinity of negative e to the negative b minus negative e to the negative 2. E to the negative 2 is just a number, so that's not a concern here. What our concern is this guy. And as b approaches infinity, negative b approaches negative infinity, and e to the negative infinity is going to be 0. So we have 0 plus some number. So that tells us that the integral from 2 to infinity of e to the negative x dx converges. And since e to the negative x is always bigger than 1 over 1 plus e to the x, what we have is that the integral from 2 to infinity of 1 over 1 plus e to the x dx also converges. Next, let's take a look at the same example that we just did, but instead of from 1 to infinity, we're looking at 1/2 to infinity. So we want to compare it to 1 over e to the x. But we can't quite do it just yet, because if we look at the graphs, 1 over e to the x looks something like this. So let's say that's e to the negative x, but e to the negative x squared looks something like this. And this intersection value is going to be at 1. So if we integrate from 1/2 to infinity, we have this area here where where e to the negative x squared is actually larger than e to the negative x. So in order to rectify this situation, we just split up our integral. And we integrate from 1/2 to 1 of e to the negative x squared, and we integrate from 1 to infinity of e to the negative x squared dx and dx. Now we know that this converges, right? And that's just the last example. So all we have to do is check convergence here. And if we use Mathematica or like the Wolfram computation system, we get a number. So we get that this integral is approximately 0.29, which is less than infinity, and it's greater than negative infinity, so this is just a number. So that tells us that the integral from 1/2 to infinity of e to the negative x squared actually converges. So the purpose of this example is to say we can compare the tail ends of things and check that for convergence if we know the first part of something converges. And if the first part of something diverges, then the whole integral. For our final example, let's look at the integral from 1 to infinity of 1 over the square root of x minus 1. So as we go out towards infinity, the 1 in the denominator doesn't really matter. So this is going to look kind of like, so it looks like 1 over the square root of x as x approaches infinity. So that looks like a really good candidate for our comparison. So we want to compare it, so we want to compare to 1 over the square root of x. We want to compare it to this integral, which we know diverges. So what we need to show, so we want to show that 1 over the square root of x minus 1 is greater than 1 over the square root of x, greater than or equal to. And that's going to be for every x greater than 1, or greater than or equal to 1. So we know that the square root of x minus 1 is less than the square root of x. And that tells us that 1 over the square root of x minus 1, we just take the reciprocal of everything, it's going to be greater than 1 over the square root of x on 1 to infinity. And that tells us by our comparison test that if the integral from 1 to infinity of 1 over the square root of x diverges, since it's smaller than the integral of the bigger one, 1 over the square root of x minus 1, also diverges. And we know it diverges because this is 1 over x to the 1/2. And 1/2 is less than 1. So that tells us that this integral from 1 to infinity of 1 over square root of x goes to infinity. And since this diverges, our original